Second, science of humidification, why moisture matters. Have you ever thought about how crucial air moisture is? From cooling massive power plants to keeping food fresh, humidification quietly power industry. It's an unseen hero making environment more comfortable and efficient. Humidification isn't just about adding water to the air. It is precise science. Cooling tower in power plant rely on it to prevent overheating. HVAC system maintain perfect indoor condition by balancing moisture for health and comfort. Even food storage relies on humidification to lock in freshness. Imagine factories unable to cool their machinery or produce spoiling in transit. Without regulated air moisture, efficiency fail, costs rise, and sustainability goes derail. Humidification keeps processes running smoothly, safeguarding industries and even impacting your everyday life. Modern humidification systems are smarter than ever, using advanced automation to optimize energy use and resource consumption. They represent a balance between technology science and the environment, fostering progress across industries while aiming for sustainability. Ready to uncover more about the intriguing role of air moisture in shaping our life? Hit like, follow for more knowledge-based content, and share this video with someone who loves to learn how the invisible science of humidification impact their daily routine. Meet the cooling tower, the superhero of humidification. Ever wonder how large building or factory stay cool? Enter the cooling tower, a true superhero in the world of humidification. Imagine a quirky tower juggling stream of air and water, working behind the scene to cool warm water through evaporation. Science meets superpowers. Picture this warm water flow down like a cascading waterfall, while air zoom outward like a superhero taking flight. When they meet, magic happens. Water loses heat through evaporation, and the air becomes humidified, but there's a catch. The cooling can only go as low as the wet bulb temperature. Let's play detective. Why can't the cooling tower cool beyond the wet bulb temperature? The answer lies in evaporation. As water evaporates, it transfers heat into the air. When air can hold more humidity, the cooling stops. Ready to uncover more amazing science? Wasn't that cool? Now it's your turn to become a humidity detective. Share this video with friends and explore how cooling tower impact daily life. From malls to power plants, subscribe for more fun and educational science adventures. You don't want to miss the next chapter. Keep learning and stay curious.
Cooling tower is heat rejection device that extracts waste heat from building industrial process and release it into atmosphere. Hear how a cooling tower is working. Cooling system components is including cooling tower, recirculating pump and heat exchanger.
Cooled water from basin is pumped through heat exchanger. Cooling tower picks up heats and temperature will increases. Warm water distributed over top water. Air moves past warm water. Then it's evaporating a portion of the water and it will cool the remained water. As the basin water level drops, fresh makeup water added. Evaporated water leaves behind and dissolved impurities from makeup water which concentrated and cause scale, deposits, and corrosion. Concentrated impurities in tower are removed through blowing down tower water to drain. The basin water level drops due to this evaporation and blowdown losses, and more makeup water is added to maintain levels. Open recirculating cooling towers save tremendous amounts of energy and reduce greenhouse gas.
So for humidification and its application, we choose example 10.51. So the question asks to calculate the height packet tower Z. After we read the question, we can extract all the important data like G, water flow rate of L, TL2, TL1, wet bulb temperature, kGA. After we extract the data, we can easily understand to answer the question.
So, the first thing we need to do is to draw the operating line. So, the first thing we need to do is to find the H11. So, from the data given, it shows that 23.9 is for the wet bulb and 29.4 is for the entering air in the dry bulb. So, we need to plot these two temperatures into the humidity chart, and we draw the line for the wet bulb until 100% because it is fully saturated, and for the dry bulb until 60% because it is constant relative humidity. Then we connect these 2 points. Then we connect the line until the humidity line of y-axis. Then we get the humidity of 0.0165. After that, we can find the Hy1 from the equation 9.39 from textbooks. So we substitute the value that we got into this equation and we got 7.17 kg over kg. Then we use the value of Hy1 to plot the operating line.
So to draw the operating line, we need Hy1 and Hy2. We already get the Hy1s. So next, we need to get the value of Hy2 in order to plot the operating line. So the easiest way you can do is just put all the data given in the equation 10.52 as what is shown here. So Hy2 is 129.9 multiplied with 10 power of 3 joule per kg dry air. After we get the Hy2 value, we can plot in the graph. So we know the value of TL2. So we measure the TL2, the value of TL2 at x-axis, and then we find the value of Hy2 at y-axis, and we plot them, and we just connect the Hy1 with Hy2 like this.
Next, we want to find the value for HYI, HY. To create the table that consists of HYI, HY value, and HYI minus HY, and 1 over HYI minus HY. Okay, so how to get the value for HYI? So first, I will make a line from operating line to equilibrium line by using the value of the slope, which is negative 41.87. Then I make the line not just one, I make 1, 2, 3, 4, 5, 6 line on the operating line. And then from the operating line, I will draw the line to equilibrium line and then direct to the y-axis. And then we will get the HYI value. And for the HY value, we will pull straight away from operating line to y-axis, and we will get the value for HY. After we get the value for HYI and HY from the graph, we will create a table that has the value for HYI, HY. Then we have to calculate the value for HYI minus HY, and then we have to calculate the value for 1 over HYI minus HY.
So, for this part, we will integrate the value and use this formula for our integration. So, for this part, we calculate the average of 1 over HYI minus HY. So, first, we sum all of the value of 1 over HYI minus HY over 6 because there are 6 values, and we got the answer is 3.127 exponent negative 5 J per kg. So the next part is we do the integration, which is we got the answer is 1.82 meter. So this part we can find the height of cooling tower Z, and this is the formula. So we put all the data given in the formula times with 1.82, and we got the answer is 6.98 meter as our height cooling tower.
Next, let's go to the practical application of humidification. This principle have wide application from power plants to industrial cooling system. Understanding humidification ensures efficient operation and environmental sustainability.
Challenges like water quality and energy efficiency are crucial considerations. For instance, impurities in water can cause scaling, while excessive energy use can reduce system efficiency. Addressing these issues through filter water and optimized design is essential.